Good morning, students. As you can see the title today, work done by the force acting obliquely. So today we will talk about the force which will act obliquely. Means the force is acting with some angles. As you can see in this picture, a boy is pulling a car. Okay. So here you can see the direction of force is different and the direction of motion is quite different. Okay. So in these cases, how does the force works? What kind of, how will we calculate the work, that we will going to learn in this video. Okay, so um, as you saw in this picture, okay, in those cases we cannot use the formula W is equal to Fs to calculate the work done, because the distance moved S is not exactly in the direction of the applied force. Okay, we have talked earlier that the work is force into displacement. So the displacement is a vector quantity, it has a direction. Okay, so when the displacement has direction, we need to have a exact direction with force. Okay, but here when the force acts obliquely, in that case the direction of force is something else, and the direction of motion is quite something else. So because of that reason we don't use the formula W is equal to Fs. Okay, because if we will use this formula, then we'll get a wrong answer, because the direction of force is not exactly with the direction of motion. Okay, so the formula for work done when a body moves at an angle of the direction is W is equal to F cos theta into S, or we can say that Fs cos theta. So F is the force applied and theta will be the angle between the direction of force and the direction of motion. Okay, and S will be the distance moved. So when we talk about theta, theta is the angle between the direction of motion of the body and the direction of applied force, means in whichever direction, whether it actually look at this picture. Okay, here theta, you can see at the place theta is here. So the value of theta can be anything, like 60 degree, 45 degree, 30 degree, 90 degree. So we will have to calculate the direction, or we will have to calculate the work done with the help of this theta, because the theta is working along with the force. Okay, so now when theta will be 0 to 90 degree, okay, in those cases you will have different values, okay, according to that. But when theta becomes 90 degree, exactly the 90 degree, in that case, as we know that cos 90 degree, actually this you will study in class 10, that the different values of theta. So for now I will tell you that the cos 90 degree is equal to 0. Okay, cos 90 degree has the value 0. Okay, so as we will have 0 here, so the total work done will become 0 by itself. Okay, so keep this in your mind whenever the angle theta will be 0 degree. I'll give you some examples that when, in which cases the theta becomes 90 degree. Okay, so whenever theta will become 90 degree, the force, or actually the total work done, will become 0. Okay, look at this picture here. This man called coolie has kept all the luggages on his head. Here the direction of force, in which direction he is applying force, towards his head. So while keeping the he is applying the force, and the direction of motion, okay, is quite different. So he will keep the luggage on his head and then he will move forward. What will become the theta? Here the angle will become 90 degree exactly. Okay, So in this case, what work he will do? So as per physics, he will do nothing, okay, because here as theta is 90 degree, means the application of force is in 90 degree. So that's why that makes complete value of work done 0. So we can say that whenever um, someone has kept something on his head, okay, in those cases theta becomes 90 degree and the work done becomes 0. Okay. Now we will see that when the force will become positive, when it will become negative, and when will it become 0. So as we saw that whenever force is applied in the direction of right angle, in those cases the work done becomes 0. So now when the force will be positive and when the force will be negative, that we will see. So the work done is positive when the force acts in the direction of motion of the body, okay, when the force is in the direction of the motion. For example, if you are kicking a football, okay, you will kick on the forward direction, the football will move in the forward direction only. So the applied force and the angle and the direction of motion both are same. So in that case, the work done will become positive. When it will become negative, the work done is negative when a force acts opposite to the direction of the motion of the body. So whenever the direction of motion of the body will become opposite to the applied force, okay, in those cases the work done will become negative, and the work done will be 0 when the force acts at the right angle on the direction of motion of the body. Okay. Here you can see the picture of a satellite. Okay. Why I have kept this picture over here? Just to tell you that what kind of force acts on the satellite. Okay. As you all know that the satellite moves around the planet, okay, or the earth moves around the sun. Okay. Why does it move around the sun? Because of the gravitational force acted by the sun, right? And why does the satellite moves around the planets? Because of the gravitational force applied by them. Okay. So that is the case. So as we know that if we will apply force, okay, in some direction, we will lose our energy, right? And if we will continuously lose our energy, then a time will come when we will not be able to apply force, right? So in that case, the for example, I'll tell you that like earth is applying some force on the satellite just to keep that satellite in its own orbit. So what will happen? So when the earth will continuously apply the force on the satellite, earth will lose its energy continuously, and once it will lose its energy completely, the satellite will fall down on the earth, right? But does it happens? No. Actually, satellite doesn't fall on earth. Why it doesn't fall on earth? Have you ever thought about it? Why the planets move around the sun and never falls on the sun? Because sun is applying a force of gravity on it, so the planet should fall on it, because sun is continuously applying force, or sun is continuously using its energy to keep the planet on its own orbit. So in that case it has to fall someday on the sun, but it doesn't. Why? So the reason is over here. Look at the direction. Here the this one is earth and this one is satellite. So the earth applies force in this direction, the reaction, and the direction of motion of satellite is this one. Which angle can you see over here? Which angle do you see? Hmm? So here This is a right angle, isn't it? As it is a right angle, so the complete force becomes 0. So total work done will become 0. So what kind of work the earth is doing on the planet satellites to keep that in its own orbit? It is doing exactly nothing, right? So as it is doing nothing, so earth is not applying any energy on that, which means if we will not apply any energy on doing something, what will happen? We will not lose our energy, and the satellite will keep moving on its own orbit, and it will never fall on the earth because the energy is not being lost over here. Okay, hope you got this point, and if you have any doubt regarding it, you can ask me, you can text me your question. Okay, so this was it for today. Catch you soon for the next lecture. Till then,